Okay, so for our project, we're going to use this book of mass 2.6 kilograms and slide it down this ramp of length 1.2 meters and use this iPhone to measure how long it takes for the book to get from the top of the ramp to the bottom of the ramp, and then use energy, kinematics, and dynamics to measure the coefficient of friction between the book and the wood. To find the angle of this plane, we're going to use this protractor and measure this, which is 66 degrees, and then we know if this angle is 66 degrees, then the angle of this is going to be 90 minus 66 degrees, which is 24 degrees. Go.
Okay, so in order to find the coefficient of friction, we're going to have to use conservation of energy. So we know that energy naught is equal to energy final, which means that potential energy and kinetic energy initial will equal potential energy and kinetic energy final. But we also know that some energy will be lost due to heat from the work done by friction. So then we have, and we know that work equals force times distance, but again it's the work done by friction, so it's going to be frictional force and distance. So we know that it's mgh. It starts at 0. The box doesn't move. Mgh final, or 1/2 mv squared final, and frictional force times distance. But then, oh shit, we have to use protocol. So we split the whole box up into free body diagram, and then we took the force of gravity and split it up into its components. We know that F naught is equal to Fgy, and force gravity in the y direction is going to be the cosine of force gravitational. So then, coming back to this, we know that this is going to be frictional force mg cosine theta all times distance, and that will be our equation.
And at this point, we need to solve for the final velocity, so we're going to use kinematics, and we're going to use this basic kinematics equation, and we know that the initial distance is 0, so that is going to cancel out to 0, and we know that the velocity initial is 0, so that's going to cancel, and then you're left with the final distance equals 1/2 acceleration times time squared. Solving for a, we get a equals 2 times the final distance divided by time squared, which equals 0.6 meters per second squared. And then you take that acceleration and bring that into another kinematics equation. Velocity final equals velocity initial plus acceleration times time. And you know that the initial velocity is 0. So velocity final equals acceleration times time, which when you solve it out comes to 1.2 meters per second. Stop. Alright, and from here, now that we've solved for the final velocity, which is 1.2 meters per second, we isolate mu, and you get gravity times the height 1 minus gravity times the height 2 minus 1/2 the velocity final squared divided by gravity times cosine theta times the distance, which when you plug that into your calculator, it ends up that mu, the coefficient of friction between the ramp and the book, equals 0.345.